Let's take a look at this problem. Working with elasticity, and P is equal to 800 over x plus 8. Now we could rewrite that as 800 times x plus 8 to the negative 1, because this is like the first power, and I could bring it up on top. I do that because I know I need P prime for my elasticity formula. So I take my power, put it out in front, so I got negative 800, x plus 8, lower my power by 1, times the derivative of what's inside the parentheses, but the derivative of x plus 8 is just 1. So that gives us negative 800 over x plus 8 squared. Okay, now eta, and I draw it bad, so let me show you what one should look like. That's what eta looks like. Okay, is equal to p over x all over p prime. Well, p is 800 over x plus 8 over x, all of that over p prime, which is negative 800 over x plus 8 squared. Well, on the top here, I got a single fraction over the denominator, so I can take this denominator and put it with this denominator. So we got 800 over x times x plus 8 all over negative 800 over x plus 8 squared. Now I could rewrite that as the top part divided by the bottom part. And division we rewrite as multiplication, so I got 800 over x times x plus 8 times x plus 8 squared over negative 800. Now I can do a little bit of canceling. The 800s will cancel, and here's an x plus 8, and here's two x plus 8s. So the 800s, this becomes 1, and then this becomes negative 1. This x plus 8 is going to cancel with one of these x plus 8s. So I'm going to end up with 1 over x times x plus 8 over negative 1. Now if I multiply those together, eta is going to be equal to x plus 8 over negative x. Okay, that's eta. Now, specifically, we're going to look at the intervals, because they're kind of interesting on this one. The absolute value of eta is equal to 1. This is the equation we analyzed to figure out where something changes from elastic to inelastic. Well, if I plug that in, I'm going to have the absolute value of x plus 8 over negative x is equal to 1. Now, an absolute value equation, you drop your absolute value, so we got x plus 8 over negative x, and you set it equal to positive the other side, and you drop your absolute value, and you set it equal to negative the other side. Now, my first equation here, I multiply both sides by negative x, and we got x plus 8 is equal to negative x. Take that x over, and we get negative x minus x. 8 is equal to negative 2x, or x is equal to negative 4. Now in this one, I multiply both sides by negative x, and we get x plus 8, and negative 1 times negative x is a positive x. Take the x over, and we end up with 8 is equal to 0, which that drops away because we don't have an x. So this is our x value, where it changes, which doesn't make any sense, does it? Because typically you can't have negative x's here. So if I put in a test case of negative 5, that didn't make any sense. And negative 2 wouldn't make any sense. So actually, the only one that even would remotely start making sense, 0 wouldn't, but 1 would. Now, it does weird things if you put 0 in there. I encourage you to try it and see what happens. Let's plug in 1. And we're going to plug that into the absolute value of eta, which is the absolute value of x plus 8 over negative x. So if I put 1 in there, 1 plus 8 over negative 1, which 1 plus 8 is 9, divided by negative 1 is negative 9. The absolute value of 9 is 9, which is greater than 1. Which tells us Greater than 1 means it's elastic. So this is elastic everywhere. So this is elastic when x is greater than 0. Okay. What they're specifically asking about in this problem is x equals 25. Well, automatically it's elastic everywhere. So it's going to be elastic there. We don't consider negative values because negative values is how many you've sold. And that usually what a negative value might indicate a return. So it doesn't really make much sense for what we're looking at. Okay, well, let me actually find eta, just so you see what the value is. Eta, without the absolute value, is x plus 8 over negative x. So we would have 25 plus 8 over negative 25, which gives us 33 over negative 25, which, let's see what that is. There it is. 33 divided by 25. So we get negative 1.32. And then the absolute value of eta would give us a positive 1.32, which is greater than 1. We already know it's elastic, so there's no big surprise there.